1 and then set 2. So this was a mock paper 6, set 1. The first question, the student is finding the density of a water by two methods. In method 1, what he did, he used a force meter. He measured the weight of the modeling clay, record W1 on the piece of a modeling clay shown in figure 1.1. Means what is the weight of this? What is the value shown? You can annotate on the screen if you want to. What is the value shown on the screen on the force meter? So that is equals to 1.5 Newton. Okay. So 1.5 Newton is the value which is shown on the force meter. The next one, record the volume V1 of a water in the measuring cylinder in figure 1.2. What is the volume of the water in the measuring cylinder? What is the level? We always read the bottom of the meniscus. What is this number? Yeah, what is this number? As you can see, this is from 0 to 25. How many lines are there? 1, 2, 3, 4, 5 lines. So it means if 5 lines are representing 25, each line is representing 5. So what is this value? It is 155, not 160. Because if you see, we have 0, 5, 10, 15, 20, and 25. Because there are 5 lines, or 5 divisions are there. So we have a 5 divisions or 5 lines are representing 25. So what one line is representing or one division is representing, it will be x. Cross multiply. So x will be equals to 25 divided by 5. So x is equals to 5. Means each line is representing 5. So this is 150 and it's the first line after 150. So first line after 150, that will be equals to 155. So the value which we should write there of V1, that is equals to 155, and the unit is already given in CMQ. Describe how a measuring cylinder is read to obtain an accurate value, and you may draw a diagram. So if you want, we are using a measuring cylinder to record the volume of the water or the volume of the object as it or how much it has been displaced the liquid. So what we should do, we should draw a measuring cylinder. So view the cylinder at the eye level, yeah, and read from the side, read the bottom of the meniscus, like look for the bottom of the meniscus, look perpendicular to avoid a parallax error, and check, read from the side of the marking. So 3 points you should always list whenever you're using a measuring cylinder. If any one of you did not receive the paper after marking, send me your PDF, which you did not receive. I will send it after the marking. But I have marked all of them. So in case if you did not receive paper 6, not paper 2, paper 6 are all marked. So in case if you did not receive your paper 6 or paper 4, you can send the PDF and I'll return that. So the points you should list here, look perpendicular, look for the bottom of the meniscus, and look for bottom meniscus. Whenever we look perpendicular, it means we are avoiding a parallax error. And bottom of the meniscus, because we have a lower bottom meniscus and the top of the meniscus. So for water, we always read the bottom of the meniscus, and we will should read from the side of marking. The side where we have the marking, that side we should read the measuring cylinder. So these are the points you should always list whenever you are using a measuring cylinder in a paper 6 question. Okay. And in the question, it is optional. They ask you may draw a diagram. So if they say you may draw a diagram, you should draw a diagram. Why? Because when you draw a diagram, maybe you miss any point in the explanation. So your diagram will cover that point. Yes, any questions, Jahan?
No, sir, I was just going to ask, like, do we have to draw the diagram?
Yeah,
Is
you
it
should draw. Even look, it's an optional, but this I advise student to draw a diagram. Even it's an optional. The reason is that maybe your explanation, your point, you may miss a point in writing, so your diagram will cover that point. When you draw, like when you will draw the
Sir, what if we can't draw?
what? Yes, Araf.
What if we cannot draw?
Why you cannot draw? You have to draw. So you will draw an eye level on the side of the marking, look for the bottom of the meniscus and read the scale. So if you cannot draw, practice these diagrams, okay? The next is, you can see the next is a measuring cylinder is there, which is filled with a liquid and the object is immersed into this measuring cylinder. Record the student lowered the modeling clay into a water. Record the new reading for W2. What is W2 here? What is a reading? Here, how many lines are there? If you count, like we have 1, 2, 3, 4, 5. So 5 lines are there. So each is representing 0.1. So this is how each line is representing 0.1. Like this is 0.1, 0.2, 0.3, 4, 5, 6, and 7. So this is right. That is 0.7. If the unit is not given, then in paper 6, the unit, writing a unit also having a mark, okay? So some cases they write the unit, that is not having mark, but some cases they don't write the unit. In that case, you have to write a unit. A correct unit will score a mark with the question, okay? So
Sir,
here,
I've
yes?
in my school, they said that if they give the unit and you write the unit, you will you'll get the complete question wrong.
No, no, no. The unit is already given, so you're not supposed to write a unit here. I'm saying in this case, like you can see, there is no unit shown. So here you have to write a unit. You're saying if you write 0.7 Newton and a Newton is given already, so no need to write this Newton here. Clear?
But if I do I get the whole question wrong or I still get marks?
Actually, then it depends on the examiner. Right? Like you're giving option to the examiner that whether he accept or no. If so instead of giving an examiner an option to make it right or wrong, then examiner is having full liberty to make it wrong. Like examiner, it's totally based on the examiner. If you write the unit here, Newton, and Newton is already given, maybe the examiner will consider your value only, or examiner consider the Newton is written and you write the unit, so he can deduct mark. So instead of giving option to the examiner, better you uh, see if the unit is not written, then you should write. If unit is written, no need to write the unit there. Okay. So it's not a rule that if you write
Okay.
a unit, like it's not a rule that if you write 0.7 Newton, you will lose the mark. No, that totally based on the examiner. If we include only your number, magnitude, yes, you will score the mark. Then record the new reading V2 of a measuring cylinder with a piece of a modeling clay. As we know, each line is representing 5. So what is this number? 235. That's right, Farzan. So we have 235. So it's already given cm cube, so we don't have to write. And W1, it was 0.7 Newton. Now calculate the density of a water using the reading from A, B, C and the equation. So what was W1 for us? The W1, it was 1.5. W2 was 0.7. the final volume was 235 and the initial volume was 155. Now, this is of 2 marks. So how you score the mark? 1 mark is for writing, but when you write the answer, write in 2 significant figure, okay? Whenever you write the answer, write in 2 significant figure. So you should write as 1.0. And what should be the unit? The unit is gram. So 1 mark is for the unit, grams per centimeter cube. 1 mark is for the answer. Okay? Is it clear?
Yes, sir.
So in a method 2, what student did? In method 2, what student did? Student removed the modeling clay from the water and he places a measuring cylinder on the balance. So as you can see, he places a measuring cylinder on the balance and he is recording the mass of the measuring cylinder and the liquid together. The reading of the M1 of a measuring cylinder is shown. Record M1 nearest to gram. So how much I should write in gram? What should be the number?
241.
241. If you round it off to nearest gram, like you need when they say a nearest grams, it means you need a whole number. And 240 is not the right here because when I round it off, this will be 241 grams. So we should write 241, not 240, because we just want a nearest gram, like we need a whole number. The student pour a water out of a measuring cylinder and he measured the mass M2 of the empty measuring cylinder, which is 93 grams. Now calculate the second value of a density using B, E, and F. So what was M1? It was 241. M2 is 93, and the volume, how much is that? V1, it was, I guess, 155. Yeah. So what's the answer here? 0.95 grams per centimeter cube. Then calculate an average density of a water using a density 1 and density 2. The density 1 was 1.0 and the density 2 was 0.95 and divided by 2. What is the average for us? Zero 0.975. Okay. Write your answer. In this case, look, how many significant figure I should use? How to know this? Look, some examples, as you can see, for here we were having 2 significant, 3 significant, 3 significant figure. So we were using 3 significant figures in our calculation. So the final answer should be in 3 significant figure. If all my values were in 2 significant figure, then my final answer should be in 2 significant figures. Is it clear? Like how many significant figure I was using in my calculation, the same number the final answer should be. Now, the 2 methods suggest a possible source of inaccuracy in either of a method 1 and a method 2 and explain how an improvement might be made to reduce inaccuracy. So you wrote rocks in method 1 had pores. Yes, that's right. Because look, I will explain the 2 methods, what we did in the first method and what is done in the second method. Yes, Farzan, that was correct, your point. Just I will scroll up. Look, in the first method, what we did, we got the weight by using the spring balance or a force meter. Then we use a displacement method we use a displacement method to know the volume. Okay, volume, that's how we got the volume. And the weight we already know using a force meter, and we use a formula, we got the density. That's the first method. So in a first method, what might be a possibility or inaccuracy that this modeling clay may have air holes? Like it's not a solid piece of modeling clay, maybe air holes are there. So when we put this inside the water or a measuring cylinder, that air will escape and that water will take up the volume. So that will cause an inaccuracy in the measurement. That is one possibility is there. So there might be air bubbles are there. Another thing, because what we are doing when we put this inside the measuring cylinder, maybe what might happen, some of the water might spill. That is another inaccuracy in and that will reduce the volume. So what we should do to overcome this inaccuracy, we should place it gently or slowly immerse the modeling clay into a measuring cylinder. They said experiment was when they say experiments were carried out carefully, what does it mean? Means accuracy of the experiment, like reading errors are not there. Like you cannot say the parallax error. You cannot say a parallax error. No. When they say experiment is done accurately, it means errors due to the instruments or the techniques are not there. Like you cannot say that parallax error in the measurement, that you cannot say. The zero error in the this one spring balance, you cannot say that as well. Maybe the spring balance might deformed or there might be a zero error. So that you cannot say, that is not acceptable. That is what they mean, that the experiment is done accurately. So errors due to a technique like looking perpendicular, avoiding parallax, or instruments are not there. Is it clear? So that you cannot mention, rest you can mention. You can mention that, like example, maybe what you did here, you measure the mass of empty, you measure the mass of filled measuring cylinder, and then you measure the mass of empty measuring cylinder. So what might happen when you empty the measuring cylinder, maybe some of the liquid might remain in the measuring cylinder. That is another possibility. Not all of the liquid being transferred. So these are the possible points you can mention. Okay. Yes, Zahan, you have a question?
Sir, may I go to the bathroom?
Yes, sure. Okay, look. So what we can do, yeah, I will repeat, Abdurrahman. So in the experiment, what we did, the first experiment, we use a spring balance, the method one, we use a spring balance and we attach a stone, modeling clay, I mean, we measure the mass, like weight actually, and then we pour this into a measuring cylinder which is filled with the water, and we measure the change in the volume, the difference in the volume, to know what is the volume of the object. So mass divided by volume, we got the density. That was the first experiment. And the experiment is what? The experiment is density of the water we were using with this concept, okay? The second method, what we did, we may fill the measuring cylinder with the liquid, the water, and we place on the balance, and then we measure the mass of empty measuring cylinder, and we took a difference in the mass divided by volume, we got the density. That is the second method of finding the density of this. So what could be the reason? Inaccuracies are there. So when we transfer, like example, in the second method, when we transfer the water, maybe not all of the water being transferred, or the measuring cylinder is not completely empty. So if the measuring cylinder is not completely empty, what will happen? We will have an inaccuracy because we'll not have the mass of empty measuring cylinder. It will have some water inside. The second thing, in the method 1, when we put this object inside, so what might happen? Some of the water might splash. So that might also leads to an inaccuracy. So we should place it gently. And another thing, the modeling clay may have some air bubbles like air trap. That is also leads to inaccuracy. When you're answering such question, yes, one, you're supposed to write, can we say a clay can have an air layer? Yes, you can say that. You can also write this reason. And how you can remove the air from this modeling clay? So you should shake the modeling clay because a modeling clay may have air trap. So how you can remove this? So you should shake the modeling clay when it is inserted. Just shake the modeling clay. So you remove the air out from the modeling clay. Okay. Is it clear? Anyone having a question? When you're answering a question, yes, you can write 2 valid answers, reasons as well. Similar reasons you can write. So method 1 or method 2, so you can say if one is invalid and the other one is valid, then again it depends on the examiner. Like you're giving a choice to the examiner that he do right or wrong for you. Like if you're sure that this is the answer, write that. If you're not sure and you're writing 2 points, then totally based on the examiner. And he will write like this, which means I choose, you lose. So he will deduct the marks. So don't give options to the examiner. Keep options with yourself and answer them accordingly. Question 2.
Sir, what does I choose, you lose mean?
Means the
couldn't get-
examiner, I choose, you lose means the examiner decide that you should not get the mark. When you give an option, no, this is, I'm not joking, honestly. It is a term used by the examiner when marking the paper that if you give a choice to the examiner, then he's the one who has to decide. So if he write, I choose, you lose, it means he will deduct your mark. So if you give examiner an option to select any one from the 2, then it totally based on the examiner. So, and no one can challenge that. Moving on to the second question, some students are investigating the resistance of a power supply. They are using a circuit as shown in figure 2.1. As you can see, a power supply between P and Q, a resistance wire is there, an ammeter, a crocodile clip. A student connects a crocodile clip to a resistance wire at position at particular values, like what he did. He placed this crocodile clip to different positions, like here or here, anywhere he can place according to the length which he's using. Then he's measuring a potential between P and Q. These are the points. He's measuring a potential between those points. On a figure, draw a voltmeter to measure a potential difference between the terminal P and Q. Look, whenever I need a potential difference between the 2 points, I should connect a voltmeter between those points only. Okay. So I should connect in this manner between P and Q. Yes, you can connect like long way. That's fine. Yeah, this is also fine. But when you are crossing 2 wires, you should make a bump here. When 2 wires are crossing each other to show that they are not intersecting, there should be a bump. Yeah, this is also a right way, but it should be between P and Q only. And the correct symbol for the voltmeter. No, this is not the right. If you connect a voltmeter at this point, that is not correct. Why it's not correct? Because voltmeter is always connected in parallel. So you cannot connect, like if a student connect a voltmeter here, that's wrong. So what you should do, you should connect between P and Q. Because we want the potential between P and Q. The potential here is not the potential between P and Q. If it was an ammeter is connected in series. Ammeter should be like this, but voltmeter, no, it should be between the 2 points and it should be connected in parallel. It's okay if we connect on a resistance wire. You mean like this? You mean like this, connecting between the resistance wire? No, that's also not correct. You want between P and Q. According to the question, you have to write. If I connect before and after P, if you connect before and after P, that's also wrong. Like if you connect a voltmeter here, that's wrong. If you connect a voltmeter here, that's also wrong. This is also not right way because you cannot connect a voltmeter in one side of a battery. This will read always zero irrespective of what current is passing through because it's connected on the same wire. So they give you the reference. They give point P and Q. Just join them from P to Q. That's it. That's the best position according to the question. So voltmeters are always connected in parallel. Then we have what you wrote. Figure 2.2 shows an ammeter for a value of a voltage 2.2. Record in the table. What is the current here for a 2.2? That's equals to 0.38. Okay. Because the next we have to sketch a graph. So I'm writing the values here for a voltage and a current. Current is on y-axis, voltage on y-axis, and the current is on x-axis. 0.38, 0.47, 0.55, 0.69, and 0.76. Okay. These are our values. Now, look, in this question, they did not specify that you should start your graph from origin. They did not say that the first value should be 0. Nothing they said. So now you have an option. You can start with any number, okay? And now before you plot or select a scale, just a minute, for example, I'll scroll down for one thing. So to know that whether the graph should be a straight line, before you sketch or plot a graph, you try to read the next point. You can see determine the gradient of a line you have drawn. So because they mentioned there is a gradient in the next part, so definitely it should be a straight line. Okay. So this gives you an idea. So before you plot a graph or mark or label the axis, you can first scroll down, like on the paper, you can turn the page and check the next part of the graph, that whether it's a straight line graph is there or what you have to do. So because they ask for a gradient, definitely there should be a straight line graph. Now we select the scale. On x-axis, we need a current. The minimum value and y-axis, we need a voltage. The minimum value, look, they did not specify that you should start your graph from origin. So you can start with any number. So you can start, like example, a student started with 1.2, 1.4, 1.6, 1.82, and 2.2. That's good. That you're covered. And whenever you sketch a graph, you should at least 75% of your graph paper should be used. Next is you have the x-axis, the current is minimum value is 0.38 and the maximum value is 0.76. So if I start the axis like 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, so about 75% of the, I will cover the scale. So it's not like all the graphs should start from 0. Then we'll mark our points. What are the points? The first 2 points, 2.2 and 0.38. 2.2 and 0.38. Here 10 boxes is equals to, yes, that's right. Then one more advice I will give you regarding the plotting a graph. First thing, you put a dot, okay? Later, you will make a cross on that point, but first thing, you put a dot on that point. The reason is that because when you put a cross, it's hard to recognize the exact position where is the point lie. So best thing, whenever you're plotting a graph, you start, later you can change into cross, but when the first point is there, put a dot on that point. So like this is 0.38. Next is 2 and 0.47. Then 0.55, 1.8 and 0.55. Then 0.69 and 1.6. And then 0.76 and 1.4. One, two, three, 4.76. This is what one point 0.69. Can we also start from origin if we connect it before and after? Can we start from origin? If you start from origin, your graph will not be prominent. Like, I'm not saying it's wrong. I'm saying you want a prominent, like you want to cover a 75% of your graph paper. So if you start from origin, your values are not starting from 0 to 1.38. There's no value. So best way is selecting a scale. You might lose a mark there. And then you will draw a line of a best fit. No, this is not a, for example, what's your question? Like, is this a line of best fit? That's your question? I this for to be a line of a best fit, the number of the points above and below should look same. Like example, 2 points are above, 2 points in below, and one of the point line. So this is a line of a best fit. Small scale, but the line covers the whole area for a graph, so it's fine for the scale also 75% or more space. Small scale, but the line covered the whole area. Okay, I got your question. You're saying a line covers a small area, but you mean the points cover a small area, but the line is extended one. You're extending the line. That is what you're saying. Not really. You will lose a mark for the scaling in that case. If you're like, this is your graph paper, this is your graph paper, and your points are here only, and you extend the line. So the scale, you will lose 1 mark for the scale. No, no. In that case, it's not I choose, you lose. In that case, you will lose. There's no option for the examiner. Is it clear? The line of a best fit. Then we draw a line of a best fit and we'll take a gradient. How to take a gradient? Take 2 points on the line, not the points which you use for plotting. And the spacing between the 2 points should be 5 centimeter or more. Yeah. For this point or 5 centimeter or more, you can take the space. That's right. The first point on x-axis, you will call x1. The second point on x-axis, you will call x2. The first point on y-axis, you will call y1. And the second point on y-axis, you will call y2. And remember the formula for the gradient, which is y2 minus y1 over x2 minus x1. I'm not doing a calculation for the gradient right now, as I'll move on to the second part, but I'm explaining an idea about it, okay? Yeah, this is also called a triangle method. Why it's called a triangle method? Because when you complete these lines, it's making a triangle, the base and the perpendicular. So this method, y2 minus y1 over x2 minus x1 is also a triangle method. Some of the students, when I was reviewing their mock, When I was reviewing the mock, some of the student wrote a wrong formula of the gradient. They wrote x2 minus x1 over y2 minus y1. So you will get a wrong answer. So try to memorize the formula for the gradient, which is y2 minus y1 over x2 minus x1. So after working out, show on a graph how you obtain the necessary information. We work out the gradient. Now this is 1.8 and you should clearly show this how it is done. The next is they mention the gradient. The gradient is numerically equal to resistance, means the value of the gradient and the value of the resistance are same. So R is equals to M. So R is equals to M. R is equals to gradient is 1.8. So the resistance is also 1.8 and the unit of the resistance is ohm. So we write that as ohm. The next is suggest why is should 2 mark the question? 1 mark is for the value. 1 mark is for the unit. Like when you write 1.8, you score 1 mark. When you write ohm, you will score the second mark. If the unit on y-axis and x-axis goes up by 0.5, like 1 or 2 per unit, gradient formula stays there. The next we have suggests one practical reason why the crocodile clips should not be connected to a very short length of a resistance wire in order to obtain a smaller potential difference. So like the space or the distance, what might happen? Current too small or too high? Get overheated, that's right, not too small. Current will be too high. Look, what will happen? If you want a small potential difference, if you connect this crocodile clip here, voltage, look, this formula voltage is directly proportional to current if the resistance is constant. But what is happening here in this question, the resistance is not constant. If I connect a crocodile clip here, it's a shorter length, so resistance will be less, the current will be high. So here resistance is not constant. For a constant power supply, when the voltage is constant, when a power supply is having a constant voltage, if I use a shorter length, it will have a less resistance, so it will have more current. Yeah, so resistance is less, so the current is more. That's what I wrote. R is less, current will be high. So high current means it will produce too much heating effect. And that will affect the resistance of this wire or a circuit. The wire might become too hot. We are not changing. The power supply is constant here. Is it clear? And the last part, in this type of a question, it is possible to change the potential by using a variable resistor. We just have to draw a variable resistor here. A circuit symbol for a variable resistor.